All right, ladies and gents, let's take a look at the rest of these problems. So we got ourselves a vertical line drawn to the point -3, 2. Okay, so it's asking where is it going to cross the x-axis? So if you have to even think about that, well, the x value has to be what if it's a vertical line? Well, it has to be -3, all right? And what's the y coordinate of the x-axis? 0. So a lot of these problems are just thinking and using all those different formulas. So we have 4 sets of vertices of a parallelogram. Well, actually, we need to see if it's a parallelogram or if it's a rhombus. Could be both, either one, or neither. So let's see. To find out if it's a parallelogram, first, definition of parallelogram are the opposite sides parallel. So let's see. AB. Now we could sketch it to see what it looks like, but I'm going to, for now, assume it's ABCD. Let's see if that makes any sense. So we'd have A, B, C would be even higher and further to the right. And D, it's 4, 4, so it's between, so it's above A. It's on the same level as B on the X's, but it's right below B. So it's gotta be like right there, it's above A. So something like that. So AB, BC, CD, 80, that's our sides. So I'm going to find the slopes. Slope of segment AB, slope of segment BC, slope of segment, well, let's go CD, and 80. So I'm determining if it's a parallelogram first because, well, it's easier, and if it's not a parallelogram, then it's definitely not a rhombus. So let me mark that for a second. So I just kind of plotted these points to see which sides were my sides instead of the diagonals. We don't care about the diagonals. We're not messing with the diagonals. Actually, if it's a rhombus, we could use the properties of rhombus to see if the diagonals are perpendicular, but we're going to go along with distance. All right, A to B. 2 minus 5 over 2 minus 4. -3 over -2. 3/2. Okay. That tells us nothing at the moment. Let's look for BC. 5 minus 7. 4 minus 6. -2. And that's -2, so that's +1. Okay. CD, let's see. 7 minus 4. And 6 minus 4. It's again 3/2. So yeah, these opposite sides are parallel. So we know AB and CD are parallel. Let's check if BC and AD are parallel. AD, let's see. 4 minus 2 over 4 minus 2. So yeah, it's again 1, 2 over 2, which is 1. So first, it is a parallelogram. The opposite sides, BCAD, ABCD, are parallel. Cool. Now, is it a rhombus? Well, definition of a rhombus. All sides are equal in length. We could look at the diagonals, BD and AC, and see if they're perpendicular. If that's true, then it would be a rhombus. But we'll go with the lengths, just so we can practice the distance formula. So let's find the distance of AB. So I'll just stick that over here in blue. So looking for AB. So x minus x squared plus y minus y squared. It makes no difference what you call x1 and y1, as long as you keep the order the same. In fact, for this particular formula, it doesn't even matter because we're squaring it. But it's a good habit to keep it up anyway. So this is A, this is A, this is B, this is B. Let's see what that length is. Well, that's the square root, focus on there, whatever, of -2 squared plus -3 squared, sorry, 4 plus 9, so that's the square root of 15, 13. Yes, use a calculator. Look at you, Abby. All right, so there's square root of 13. Who cares? That tells us nothing right now. We need the sides BC, CD, and AD. We have to make sure all of them are congruent. If even one of them is not, then it's not a rhombus. BC's up. Let me just grab these down here. Any hour now. Okay. BC. Let's see, so 4 minus 6 squared plus 5 minus 7 squared. Okay, it's not. That's going to be the square root. Yeah, let's fix it first. Of -2 squared plus -2 squared. This is obviously not the same. This has 4 congruent sides, and this is 4 plus 4, which is 8. Square root of 8 is not the same as square root of 13, so I'm done. It is not a rhombus. Maybe that I screwed up somewhere. No, that's 3, that's 2, yeah, that's 2, that's 2. So yeah, not a rhombus. And there's our answer. All right, we got a couple points. It wants us to find the distance and midpoint of the segment. Easy enough. We'll start with the distance. What's called x minus x squared plus y minus y squared. Okay, well, I'm not even doing any work. We've got the calculator, right? Mode 1, type it in. Square root of 19 minus 26 squared plus 8 minus 11 squared. Square root of 58. Now the midpoint is going to be the ordered pair. Add the x's together. 2. Add the y's together. 5 by 2. Use a calculator. That's 45 halves. 19 halves. Done. Okay. Not interesting, same thing. Distance. So I would suggest writing it down and then typing in the calculator. And it is minus a negative. Just write it out, then type it. That gives me square root of 34. Midpoint, 12 plus a negative 7, sure you can write minus 7, over 2, 15 plus 18, 2, negative 19, over 2, and 33, over 2, unless I screwed up on some arithmetic somewhere. But I mean, just plug in the formulas. No real thinking involved on those. Same thing. Not going to do it again. Find the coordinates of the other endpoint. Okay, here's one working backwards. We got the midpoint, we got the endpoint. Well, we know our formula. Here's one of my endpoints. So this is, call it x1, y1. So x1 plus x2 over 2 has to equal this right here, negative 11. y1 plus y2 over 2 has to equal 23. That's the midpoint formula. Just instead of not knowing what the midpoint is, we don't know what one of the pieces is. So let's find it. Multiply through by 2, negative 18 plus x, negative 22. Add 18 to both sides and get x is negative 4. 15 plus y equals 46. Y equals 31. So it says type an ordered pair, so it makes you do that. Okay, we got an absolute value equation. Oh, this is asking us to graph, so let's go ahead and do it on MATLAB. A few minutes to log in, sorry. That was question number 15. Oh, that's one. So complete the table. All we gotta do is plug in numbers. You could use the calculator, but hopefully you don't need to. Actually, just use it. Just use it. Negative 4 and negative 10 makes negative 14. That's the value that is 14. 10, that's going to be a 0. 12, that's going to be a 2. I'm literally just plugging in x here and finding out what y is. Graph it. So what kind of equation is this? Well, it's not linear. See, that's the line tool. If you read right underneath my cursor, line tool. It's not a vertical parabola or a horizontal parabola or a circle. It must be the absolute value tool. It says plot the vertex. Okay. So it did have. How are you supposed to do this? Learning these mother functions first. It gave us these options. So one of these has to be the vertex, right? Well, lowest one is 10, 0. Let's start there. I guess it's the logic they want you to use. We're going to actually learn how to graph an absolute value mother function in a little while. And then 12 will be 2. And we can see that -4, 14 is lining up on there, so that's good. Let's save it and check it. My face is in the way, I guess. That is. Okay, so yeah, I'm glad I looked at this one. So your vertex, since we don't have anything added out here, will have to be on your x-axis. So your y value needs to be 0 for the vertex for now. And later we're going to learn how to actually graph this some other functions. That's pretty much it, guys. If you have any questions, feel free to message me on Google Classroom. Don't know what's happening Wednesday. If we're in school, great. If not, I'll make another video and we'll look at, let's see what we'll look at. 2-2, which will be drum roll, more of your distance and center forms, but applying it to circles. Yeah, graphing some circles. We will apply the distance and midpoint formula on these. Oh, remember the whole completing the square thing I said we need later? Here it is. Definitely going to want to do this one in class with you guys, so I hope we are together Wednesday. If not, I'll make a video and maybe even try and do a meet. For now, though, see ya.